I try to imagine a fellow smarter than myself, and then I try to think, what would he do?
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. My name is Jesse Lawler. I am your host, excited to bring you the 86th episode of this podcast, dedicated to the ongoing improvement of your own brain by any and all means at your disposal. We're going to be talking this week with Dr. Molly Crockett. She is, among other things, a distinguished research fellow at the Oxford Center for Neuroethics, and we're going to be talking with her in particular today about a study that she's recently completed showing correlations between medications that are not necessarily intended to have any overt consequence on moral decision-making and, you guessed it, consequences in overt moral decision-making. I came across this study a couple of weeks ago. I thought it was really interesting and potentially opens up all sorts of cans of worms about how medications that aren't intended to have consequences like this might be modulating people's behaviors in all sorts of everyday situations all the time, and got in contact with her to have the conversation that we'll be having in the main interview. So hang around for that. Super interesting talk and a really well-designed study that she did. If you hang around until the very end of the episode, I'm going to tell you how you might be able to tell a person's drug of choice from their eye color. I am not being completely facetious when I say that. That'll be in the ruthless listener retention gimmick. But for right now, let's kick things off, as usual, with This Week in Neuroscience.
Smart Drug Smarts. This Week in Neuroscience.
Okay, so this is hot off the presses. It really is This Week in Neuroscience type news. Very new. And potentially a transformative study into how memory actually works, calling into question some of our previous understandings. This was published in the journal Science, and researchers at MIT have revealed the ability to reactivate memories that could not otherwise be retrieved using a technology known as optogenetics. Optogenetics is essentially, in its simplest form, triggering behavior in neuronal cells with light. And this study was looking into an old and fiercely debated question in neuroscience as to the nature of amnesia, particularly retrograde amnesia, which follows traumatic injury, stress, or diseases such as Alzheimer's, and whether this is caused by damage to specific brain cells, meaning that a memory cannot be stored, or if the access to that memory is blocked, simply preventing its recall, but maybe having it still locked in the brain inaccessibly. Says Susumu Tanagawa at MIT. The majority of researchers were favoring the storage theory, but we have shown in this paper that this majority theory is probably wrong. Amnesia is a problem of retrieval impairment. Memory researchers have previously speculated that somewhere in the brain network is a population of neurons that are activated during the process of acquiring a memory, causing enduring physical or chemical changes. These neurons would collectively be known as memory engram cells, and if these neurons are subsequently reactivated by a trigger such as a particular sight or smell, then the entire memory is recalled. So back in 2012, Tanagawa's group used optogenetics to demonstrate for the first time that memory engram cells are in fact a thing and that such a population of neurons exists in the hippocampus. But until now, nobody has been able to show that these groups of neurons undergo long-term enduring chemical changes in a process of memory consolidation. So Tanagawa's group identified a group of memory engram cells that were tied to a specific memory, and they recorded the activity of this particular group of cells, finding that as that memory was replayed, in fact, the synapses connecting them had been strengthened. So seeing this process called long-term potentiation of those memories physically taking place within the brain, they could see that yes, this has something to do with the memory storage and consolidation process. But then they did something different. They administered a compound called anisomycin, which blocks protein synthesis inside neurons. They were doing this in mice, by the way. And so they administered anisomycin immediately after the mice had formed a new memory. And by doing this, they were able to prevent the synapses from strengthening with long-term potentiation the way that they normally would. Now, when they returned one day later and attempted to reactivate the memory using an emotional trigger, they could not find any trace of it. The animals did not seem to remember what they should have learned or what they would have learned were it not for the anisomycin. So as Tanagawa explains, even though the engram cells were there, without protein synthesis, those cell synapses are not strengthened and the memory is effectively lost. But here's what's really strange. When the researchers reactivated the protein synthesis blocked engram cells using optogenetic tools, they found that the mice exhibited all the signs of recalling the memory in full. So despite the lack of long-term potentiation that would have normally happened in the memory consolidation process, the memory still actually seemed to be there and be triggerable within the animal, essentially hinting at something with our understanding of the way that memories are laid down and retrieved is probably still somewhat mistaken. Says Tanagawa again, if you go directly to the putative engram-bearing cells and activate them with light, you can restore the memory despite the fact that there has been no long-term potentiation. Further studies by Tonagawa's group demonstrated that memories are not stored in synapses strengthened by protein synthesis in individual engram cells, but in a circuit or a pathway of multiple groups of engram cells and the connections between them. We're proposing a new concept in which there is an engram cell ensemble pathway or circuit for each memory, he says. This circuit encompasses multiple brain areas, and the engram cell ensembles in these areas are connected specifically for a particular memory. This is one of those findings that really, I want to see a visual demonstration of, because it makes, from the sound of it, it sounds like a single memory, of which we obviously have a countless number, is collectively stored among a really, really complex array of different cells in different parts of the brain, and it just literally boggles the mind that that is the most efficient way of storing memories within our brains. So yeah, this one study into how amnesia works or doesn't work, having a major impact on our overall understanding of memory consolidation and retrieval. So we got several very positive reviews on the iTunes store this week, but I actually went into the treasure trove of iTunes reviews from outside the USA. You have to kind of look through it separately to see things from different countries, and I don't do that all the time. But anyway, I'm gonna kind of go into the backlog and talk about some iTunes reviews from non-USA reviewers that have been sitting around for a while. Sorry that I haven't gotten to them, but now I will. Kilo 9 Romeo from Canada said, "Okay, so I love the podcast. I've been going over all the old episodes that interest me. The guests are known in their fields and have lots of interesting bits to share." Shadow CA7 from the UK said, "This is by far my favorite podcast, packed with excellent interviews, fascinating information, and tips. Keep up the great work." And Gareth Locke from the UK said, "I'm a little biased as Dr. Don Kernay just mentioned my PhD work on human factors in scuba diving incidents." Okay, I could see where that would bias somebody. "But the podcast covered some exciting work going on that I wasn't aware of. Keep it up. I'm subscribed." So thank you to all of you from around the world who have left these reviews on your relevant iTunes stores, and we'll get back to the USA reviewers next week. But whether it's iTunes or Stitcher or some other syndication platform that you subscribe to, definitely appreciate the positive reviews. It helps the algorithms help us, and it is a great way of seeding us out there to the internet universe. I also wanted to thank the people that took the time to tweet at us this past week, the people that hang around until the end of the episode and heard that little tweet tag message that I put at the end of the last week's episode. Your tweets were not missed, and they definitely were appreciated. We'll probably play the same little game this week, but you will have to hang out until the end to find out what I'm even talking about. And I'd like to throw out a special thank you to listener Ryan Ostendorf, who sent in a photo as well as an email. He ordered mitogen, our mitochondrial stack that we launched a couple of weeks ago from the axonlabs.io website, and said that one of the main things he was excited about was that ordering mitogen allowed him to consolidate some of the things that he had in different individual supplements within his medicine cabinet into that one pill, and then went and listed what he had in his medicine cabinet. And this was a long list. I've seen some big nootropic stacks in my time, but I was very impressed. I asked him to send a photo of all his pills arrayed, and he actually did. All the pills lined up look a little bit like a segmented centipede or something like that. But yeah, definitely appreciate everybody that's been an early adopter of the Nexus and Mitogen stacks that we just launched. It's been super fun watching that process and that whole website come alive. At this point, believe it or not, over the course of the past couple of weeks, that website's actually gotten more traffic than the Smart Drug Smarts website, if I'm not mistaken. I'm not sure how I feel about that. I don't know if that trend will continue or not, but either way, it's been super cool, and that definitely helps to support this show. So I want a big thank you to everybody that has tried out our initial stacks over there. Again, that's at axonlabs.io. I should also throw a thank you to Zoe Corbin, a writer for the UK Observer, who cited our podcast in an article that she did on smart drugs in Silicon Valley that came out a week or so ago online and in the print edition. It was nice to get a write up there and see a little bit of an uptick in our web traffic based on that. It's nice when the traditional media can shine a little spotlight on some of the stuff going on online, and we definitely appreciate that. And if you missed that article, an excellent way to stay up on such things is with the Smart Drug Smarts newsletter, which we do have, which I talk about semi-obligatorily about once an episode. You can sign up for that online at smartdrugsmarts.com or text SDS to the phone number 33733. It's an excellent way of never missing out on anything going on within the Smart Drug Smarts universe.
Smart Drug Smarts.
Okay, so as mentioned, we're going to be speaking with Dr. Molly Crockett. Dr. Crockett is an American living in the UK. She is an associate professor of experimental psychology, a fellow of Jesus College, and a distinguished research fellow at the Oxford Center for Neuroethics. She holds a PhD in experimental psychology from the University of Cambridge and a BSc in neuroscience from UCLA. And we're going to be talking with her studying the unintended but not insignificant effects in changes on moral decision-making based on a couple of drugs that affect levels of serotonin and dopamine, respectively, within the brain. The particular drugs in question in this study were a serotonin reuptake inhibitor called citalopram and the dopamine precursor levodopa. And we should probably underscore the point that the findings on these particular substances won't necessarily translate to other substances, even if they do affect the serotonergic or dopaminergic systems within the brain. It's not to say that they don't, it's just not to say that they do either. But before we dive into this, let's talk for just a second about moral decision-making, what that actually means. So the moral decisions are kind of the interesting ones. You know, a decision between would you rather have $5 or would you rather have $20? That's not a moral decision, it's just a right-wrong decision. Similarly, most of us would say something like, should you help the old lady across the street or should you kick a baby? That's not much of a decision either. There's a clear right and wrong choice. The interesting questions in the moral realm are more the dilemmas, the times when a person is forced to choose between a greater of two goods or a lesser of two evils. For example, if you're going to be helping the old lady across the street, how does that get affected if you know that the old lady is also a babysitter and she's not a very good babysitter, and every time she goes to the grocery store there's a 1.5% chance she's going to leave a baby in the back seat of the car with the windows rolled up on a hot summer day and something terrible could happen? At what point do you figure, I'm going to let the bus take out the old lady to save the baby, or something like that? So listen carefully in the coming interview about the way that Dr. Crockett designed this study to tease apart a quantifiable way of looking at these types of moral decisions that people are being forced to make. I think it's pretty clever, and unlike the traditional moral dilemma problems that are given to people, which are generally variations of something called the trolley problem, the traditional trolley problem is very absurd endpoint of the moral spectrum as far as you're actually killing somebody with your bare hands, which isn't something that most research subjects are going to have any knowledge of, how they would actually feel about that. So it's sort of a speculative thing. And they found a way in this experiment that we're going to talk about to sort of dial back the moral decision-making into a series of discrete low-level choices that I think make the measurement of people's behavior there a lot more meaningful. So let's kick things off with Dr. Molly Crockett.
I've been interested for a long time in how different brain chemicals can influence the decisions that we make. And a few years ago, I had done a study where we looked at how antidepressant drugs influence moral judgments in dilemmas where people have to say whether it's morally appropriate to harm one person in order to save many others. We found in this study that the antidepressant drugs did have an effect on these kinds of moral judgments. They basically made people less willing to say that it's okay to harm one person in order to save many others. But the dilemmas that we use in this study were quite complex. They're hypothetical decisions. And so in the more recent work, we were interested in really drilling down on the mechanism. How do these drugs influence morality and moral judgments? And can we actually see different effects of different drugs on how people consider harm to other people?
In the original study, was this variation of the trolley problem where throwing a lever makes you more personally culpable but can save a larger number of people, something like that?
That's the one. We used a number of different variants of trolley problems, and what we found is that the antidepressant drug especially made people less willing to endorse harm in dilemmas where the harm was very emotional and physical. So, for example, the dilemma where there's a large person standing on a footbridge over some tracks and you can push this person off the footbridge where their body will fall onto the track and stop the oncoming train. So in the more recent work, we were interested in developing a lab test that could, in a very precise way, quantify how much people care about harming either themselves or an anonymous other person. And so we ran a number of experiments where we gave people the opportunity to profit from delivering moderately painful electric shocks, either to themselves or to someone else. And what we found in the behavioral studies, so not in the context of taking drugs, but a regular lab study, that most people had to be paid more money to shock someone else than to shock themselves by the same amount. Or in other words, they were willing to give up more money to prevent someone else from getting shocked than they would give up to prevent themselves from getting shocked, which was surprising to some people because a lot of previous work in economic experiments had suggested that people do care about others to some extent, but they care about themselves a whole lot more. And so what was interesting in this setting was that in the context of harm, people really did show a large degree of concern for other people, and they really didn't want to profit from someone else's pain.
That's actually a really, really nice finding as far as kind of how you feel about the whole human species in general.
It's true. We were very encouraged by this finding. It's a heartwarming tale.
And you're calling that hyper-altruism, essentially, when somebody is more willing to take on pain themselves than to inflict that same level of pain on an outside party.
Exactly. So we defined altruism as being willing to pay any amount of money to prevent someone else from getting a shock. Whereas hyperaltruism is paying more money to protect that other person than you would pay to protect yourself.
Are the people actually sort of getting to taste test these various types of pain themselves so they know what it is they may or may not be inflicting on somebody else?
And that was one of the main advances that we wanted to achieve with the new test is, of course, when you're making hypothetical decisions about trolleys, the values in question are really vague, and it's not clear whether anyone can draw on their direct experience when they're making these kinds of decisions. So in the new studies, we were very careful to make sure that people were making decisions about values that they themselves had experienced. So before they do any decisions in the test, we have them go through a pain thresholding procedure where we start at a very low, almost imperceptible level of voltage, and we gradually increase it until we get to a level of pain that the participant is no longer willing to endure. And this achieves two things. It allows everyone who's going to be making these decisions to be able to experience the pain before they make the decisions. And it also allows us to match the level of pain that is delivered to the subject who's making the decisions about themselves and also about the other person who's going to receive some of those shocks. Because, of course, there are large individual differences in how sensitive people are to these shocks. And so when I'm making a decision that can result in shocks to either me or to you, I want to be sure that the intensity of those shocks is going to be subjectively matched for me and for you. So we're able to do that very precisely. And so we can be confident that when we're delivering these shocks, the subjective unpleasantness of the pain is matched for everyone. And that means that when I'm making a choice about how much I'll pay to prevent a shock to me versus a shock to you, the displeasure of that shock is equivalent for the two people.
So are the people in the same room with one another? They can see the other person or at least aware of whom it is?
So the other person is actually in a different room. And we're very careful to make sure that the two participants arrive and leave the building at different times so they don't ever interact face to face. And this is because we're really interested in altruism and the value that people place on harming another person. We're not interested in an aspect of decisions that are concerned with preserving your own reputation and making yourself look good in front of other people. So if we allowed the two participants to interact, then there would be a risk that our results could just be explained by the fact that people don't want to suffer the consequences of running into that guy in the street later in the day. So they're in different rooms, but we convince them that there is in fact another person there with a special procedure when we randomly assign the two participants to be either the decider who's making the decisions or the receiver who might receive some shocks. They're drawing these roles out of a hat, and so each participant can see the other person's gloved hand reaching into the box to draw out the role.
And is it always reciprocal? Is the person who I'm going to be the shocker for also the person who's going to be shocking me, or is that sort of a randomly assigned bag? So, for example, if I shock somebody extremely painfully, there's no reason to suspect they'll be the one making the decision about me to maybe get revenge.
There's no reciprocity in these experiments. So it's one way. If you're making decisions about someone else, they will not have the opportunity to get you back, so to speak. Although that would be a really interesting variation that we're planning to do in future work.
The two variables on this, I guess, are sort of the amount of pain and then the money value. And of course, money grows linearly, but I assume that might not be the same for the pain value of a shock. Is getting shocked by twice as much voltage twice as painful, or is it like a logarithmic scale, or does that vary person to person?
That is a great question. So one advantage of the approach that we take is we get people to make a series of decisions, about 150 decisions, where we vary across each one the amount of money and the amount of pain. And what this allows us to do is to actually fit different mathematical models to people's choices, and we can compare the evidence for one model versus another model and ask questions exactly like the one that you posed, whether a linear or a nonlinear relationship between money or shocks and subjective value best explains the pattern of choices that people make. And we've done some of these comparisons, and at least for the amounts of money and shocks which we're using, which are not huge, it ranges from 0 to 20 pounds and 0 to 20 shocks. The linear models do the best job of explaining behavior. So we don't see very strong nonlinear effects in the data, although many studies have shown nonlinear effects for money. So I think that there's probably some interesting variability there that we could look into in future studies, but at least for the instantiation that we've done so far, it seems like it's a linear relationship.
What is the upper limit of the pain that most people kind of tap out at?
It really varies a lot from person to person. And of course, there are very strong ethical constraints on what we can do in the lab. So we definitely tend to err on the side of caution when we're delivering these stimuli. The maximum voltage that we are ethically able to deliver is 10 milliamps. And for some people, this is actually not that bad at all. Some people max out and we end up having to send them home because the stimuli are not unpleasant enough for them to be able to want to pay to avoid the pain. I think that for most people, the upper end of the scale that we're using feels a little bit like a momentary bee sting or running your hand under very hot water. They last for half a second, and we deliver the sequence of shocks. If you are unlucky enough to receive some shocks at the end, then you would get 1 shock per second. So the most anyone would get is 20 shocks, so 20 seconds of unpleasantness.
So I think we have a pretty good understanding now of how the experiment design works. So now let's talk a little bit about what your actual findings were with the drugs in question, how these are modulating different neurotransmitters, and what the results were as far as people's behavior.
So we had 2 goals with this new study that was just published in Current Biology. The first goal was to try and replicate our previous finding where we had seen that citalopram, the antidepressant, which is a selective serotonin reuptake inhibitor, had increased harm aversion in these hypothetical moral dilemmas. We wanted to see whether it would increase harm aversion in these decisions about actual pain, where we could have a very precise measure of how much they disvalued harm. The second goal was to compare the effects of the serotonin drug with the effects of a dopamine drug, levodopa, which is the chemical precursor to dopamine, commonly used in treating Parkinson's disease. And there's a whole lot less research on how dopamine affects social behavior in humans. There had been a couple of previous studies suggesting positive relationship between dopamine function or dopamine release and antisocial behavior like aggression or impulsive antisocial traits in psychopathy. So we had a sense that boosting dopamine would make people either less harm averse or less hyper altruistic, essentially pushing people's behavior in a direction that's more antisocial than prosocial. And so the way we designed the study was we had 2 groups of volunteers. One group was randomly assigned to either get placebo or citalopram, and then the other group was randomly assigned to either get placebo or L-DOPA, and then we compared decision-making on the pain-money task. So we were very relieved to find that the serotonin drug citalopram did exactly what we were expecting it to do. It increased harm aversion. The interesting thing was that it increased harm aversion both with respect to other people, as we would have predicted from the moral dilemma study, but also harm aversion with respect to oneself. So it essentially doubled the amount of money that people were willing to pay to avoid being shocked, both shocks for themselves and also shocks for other people. It had a very general effect on harm aversion.
What was the level of change that you're witnessing? It broken down into numbers, dollar values or pound values. Is it doubling? What sort of marginal difference are we talking about?
So citalopram, the antidepressant drug, had a pretty large effect. It nearly doubled the amount of money people were willing to pay per shock to prevent the pain to both themselves and other people. The dopamine drug had a much smaller effect. So L-DOPA, in contrast to citalopram, eliminated hyperaltruism on average at the group level. So on placebo, we see again that people are willing to give up more money to prevent pain to others than themselves, whereas on L-DOPA, people will give up the same amount of money to prevent pain to others versus themselves.
But it never drops below that baseline. It never gets to the point necessarily where you'd be more willing to harm others than yourself.
On average, no. What we see is an equality of harm aversion for self and others on levodopa, which is a reduction in hyperaltruism that we see on placebo. But that effect is pretty small. And we're not sure why that is. There is a lot of variation in behavior on L-DOPA. So we saw some people on L-DOPA who were extremely selfish, and there were some people who were still quite altruistic. So we need to do more studies to figure out the source of this variation. One source that we did uncover through our data analysis was we can think about the effects of these drugs as varying according to someone's body weight. So we're giving the same dose of the drug to everyone who takes part in the study, but there's natural variation in body weight, of course. We have men and women in the study, and even within those groups, we have some people who are much heavier weight than other people. And so what we can see is the people who have the lowest body weight and so are receiving the highest effective dosage of the drug, so milligrams of drug per kilogram of body weight, they're actually showing the largest behavioral effect of the drug. So that's interesting because it hints at the possibility that if we were to give different doses of the drug, we might see higher doses resulting in larger behavioral effects.
Was the experiment designed that way where it wasn't matched for like a milligram per kilogram of body weight because that's how the drugs are typically prescribed to people?
There are a couple of reasons for this. One is just convention. So in pharmacological studies of this kind in humans, the standard practice is to give everyone the same dosage. I'm not really sure why that is because in animal research, the standard is to give dosage according to body weight. So that's one interesting question, and maybe something we should do differently in future research. The other reason is that the drugs are manufactured typically in standard dosages. And so my understanding is that clinicians, when prescribing drugs, will start a patient on a relatively low dose, whatever the lowest prepackaged dose is, and then that would be adjusted depending on their response to the drug. So it's a really good point. It's something I've often wondered about in these studies, reading other people's work as well. It's typical that you would give a standard dosage to everyone rather than adjust according to body weight. But our study is certainly not the first to show that the behavioral effects of the drug vary depending on body weight. So there was another study published recently by a colleague of mine also using L-DOPA, and they found that L-DOPA influenced risky decision-making and people's subjective happiness that results from their decisions. And this is affected by L-DOPA and is also varies according to body weight.
We had a dopamine episode a couple of months ago, and one of the things I remember from that was really striking was that some Parkinson's patients who are being treated with dopaminergic chemicals then go on to become gambling addicts because all of a sudden they have a craving for this stimulation, and some of them, gambling is what they're doing. And these people that have never had gambling problems in their life, all of a sudden their Parkinson's is a little bit better, but they're losing all their money at the craps table or something.
Exactly. And I think this is one very salient example of how a pharmacological intervention that is aimed at influencing one set of symptoms or behaviors, because these chemical systems are so widespread in the brain, you can have side effects that are unintended and potentially harmful.
Also potentially helpful, depending on if it's something that's making people more socially aware. Or hyper-altruism, I think most people would consider generally a good thing. It's like if we can do things to encourage that sort of behavior, that's generally good for society.
Right. And that was actually the main reason why we were interested in studying this behavior in the first place. The work that we did previously on moral dilemmas was interesting, especially in the aftermath when people were discussing the implications of the findings. And one term that got thrown around a lot was moral enhancement. And this idea of whether we can enhance people's morality by giving a certain kind of drug pharmacological intervention. And this was very puzzling to me because the moral dilemmas that we used in that original study were designed not to really have a right answer. They're called dilemmas because there's no very clear, ethically correct answer.
Yeah, the trolley problem is like a damned if you do, damned if you don't.
Exactly. And so if you adopt a utilitarian mindset where you think that the morally best outcome is the one that results in the best consequences, then you would say, yeah, you should push the guy off the bridge because that's going to save 5 lives. But if you subscribe to a more deontological view, then you would say there are certain things that are sacred. You should not do certain things like take an innocent life, and therefore you should not push the man off the bridge, regardless of what the consequences are. And so the reason why we were really interested in this new study to choose a behavior like hurting someone for money is because that seemed to us to be pretty uncontroversially immoral. And so if we could show that we could change people's willingness to hurt someone else for money with a neural intervention, that would be one step closer to the possibility of developing pharmacological moral enhancements. I don't think that we're there yet because the drugs that we used in this study, of course, L-DOPA had a rather not nice effect, and citalopram had this very general effect where it didn't specifically make people nicer, it just made people more concerned about harm in general.
I think really the interesting thing about this study isn't necessarily even thinking what it might lead to if we as a society try to dial in this sort of technology for moral enhancement, but also thinking about all the chemicals that are out there being used right now that are probably having effects on things like dopamine and serotonin levels and are going to have spillover effects into people's moral decision making that they're not even aware of currently.
One drug that I'm really interested in looking at next is adderall because it also has a dopamine enhancing effect, and it's widely used in highly social settings, in universities and so on. And it would be really fascinating to see whether this drug has a similar effect to L-DOPA, whether it has a slightly different effect. Think about the context of studying for exams and taking exams. If people are using this drug in an exam taking setting and it also makes them less concerned about harming others for personal gain, well, what's that going to do to cheating behavior, for example?
Yeah, that's one of the things anecdotally I've heard about Adderall is that it does make people a little snappier and kind of like almost robot-like and unemotional is how I've heard it described by people that have taken it. I think that would be a fascinating study to do. What's next on your hit list as far as sort of following up this research? Because, I mean, it seems like you got such interesting results on this. It certainly bears further investigation.
We're definitely interested in expanding studies to use the same paradigm but in different contexts, so both with different drugs, also with different clinical groups, and also combining drug manipulations with brain imaging so that we can drill down a little bit more into the neural mechanisms that underlie these effects. Because, of course, when you're giving someone a drug and observing the effects on behavior, even if you're taking a very precise measure of behavior, which we are doing, there's still a great degree of complexity in terms of how these drugs actually affect the level and function of neurotransmitters in the brain. So with the serotonin reuptake inhibitor, for example, there's some evidence that depending on the dose you use and also depending on how long you administer the drug for, this can have different effects on serotonin release and serotonin neurotransmission. So we're going to be interested in following up on that and looking to see how the drugs actually shape the way that brain networks for value processing compute the costs and benefits in these decisions. I guess the one thing that I would really want to emphasize is we cannot generalize the results from this study, which was conducted in healthy people, to how these drugs might affect decision-making in people who take them for medical reasons. So there are millions of people who are taking every day antidepressant drugs or L-DOPA for Parkinson's disease, and I really don't want people in these conditions to be concerned about how their morality might be affected by their drugs just because it's way too early for us to make any conclusions of that kind. We will need to do research in patient groups to fully understand how the drugs would affect moral decision-making in them. And the reason we can't generalize is because we'd expect that the baseline function and levels of serotonin and dopamine are going to be very different different in people who are taking antidepressants long term or people with Parkinson's disease compared to healthy people. And so we cannot say that the effects of the drugs we see in healthy people would necessarily be the same in people who take the drugs for medical purposes.
Smart Drug Smarts.
So thank you so very much to Dr. Molly Crockett for taking the time for that interview. She's also got a really, really solid website. Her last name is spelled Crockett, and crocketlab.org is her home on the web. We'll keep you up to date on everything that she's working on. Now, she was a very good scientist and underscored the point that they did this test on a very specific demographic of people and a very limited subset of drugs that would have effects potentially on these particular neurotransmitters. And her findings should not be taken to translate out to the wider world of users of these two drugs or of other drugs in general. She is a PhD and a research scientist and is doing the right thing about being duly cautious with her words and her work there. I'm going to be a little bit more hand-waving and crazy and just say that it seems to me we've looked at two drugs on a couple of demographics in this study and found two significant results, and it doesn't necessarily sound unlikely to me that there might be a heck of a lot of other situations like this that we just really haven't tested for and are unaware of at present, where substances that people are using on a regular basis are modulating their moral decision-making activities in one direction or another. And that's not to put a moral judgment on it or anything. It's not to say that, gosh, maybe we shouldn't use pharmaceuticals or use things that are going to have end results in our levels of neurotransmitters because they might change our behavior. I mean, as we saw in that study, some of the behavioral changes, the hyper-altruism, I think, is actually a very pro-social change that many of us would think, well, heck, that's a good thing to have people's behavior changed in that way. But I think just the awareness that there are all these potentially effective, and I mean effective in kind of the it has effects sense, interventions onto our behavioral decision-making going on all the time is really, really eye-opening. I mean, that's really what caught my attention when I read about her study and made me want to get her on this show. So hopefully you found that as interesting as I did. But anyway, now let's move along to the ruthless listener retention gimmick.
Smart Drug Smarts. Ruthless listener retention gimmick.
Okay, so it's long been held that you can learn a lot about somebody by looking deep into their eyes. The eyes are the windows to the soul and all that stuff. And here's what's really bizarre. So researchers have found that the color of somebody's eye, in this case this was a study of around 1,200 Americans of European descent, but the color of these people's eyes was a very significant predictor of their rate of alcohol dependence. The people that had light-colored eyes had a 54% higher rate of alcohol dependence than those without. So of the people in this study, there were 992 people who were alcohol dependent and 271 who were not. But the likelihood that a person would fall into one group or the other was very significantly predicted by whether they had light or dark eyes. And in fact, people with blue eyes had the highest rate of alcohol dependence. Their rate was 80% higher than people with other eye colors. This connection was confirmed by a genetic analysis. Now, of course, researchers do not know the exact reasons that underlie this link, but it seems that there is definitely a link. Previous research on people of European ancestry has shown that those with light-colored eyes consume more alcohol on average than dark-eyed individuals. And I guess it's probably not too much of an intellectual stretch to think that the consumption of more alcohol probably tracks somewhat with the rates of alcohol dependence. There are all sorts of interesting speculations that one could make as to why this might be the case. Studies have already suggested a link between light eye color and increased risk of seasonal affective disorder, which is often co-occurrent with alcohol dependence. One explanation for that link is that light-eyed people may be more sensitive to variations in light level, which in turn has been associated with abnormal changes in the production of endogenous melatonin. That's a sleep-regulating hormone, which consequently ups their likelihood of seasonal affective disorder. Anyway, interesting stuff, and if nothing else, it's interesting conversational ammo. Should you be a drinker, next time you're out drinking with people, you can probably have at least one round's worth of conversations just based on looking at everybody's eye color and then speculating about their rate of possible alcohol dependence.
Smart Drug Smarts. The podcast so smart, we have smart in our title. Twice.
Okay, you heard it. That is the entire episode, number 86. You have made it to the end. If you liked what you heard, please recommend this podcast to your friends. Leave us a review on iTunes, tweet about us, Facebook about us, do any of those things on social media. All really, really appreciated. And thank you, by the way, to everybody around at the end of the week last time who used the #StaySmart hashtag on Twitter to let me know that you got to the end. I realized that there's actually a couple other things using Stay Smart as a hashtag, but this time let's do something a little bit different. If you're here and if you're a Twitter user and you want to hashtag hyper-altruism, then that'll probably be a little bit more distinct in the Twitter universe, and I'll definitely know that you made it here. I'll throw out one more small signal flare about signing up for our mailing list at smartdrugsmarts.com, and one more highly biased encouragement to check out our stacks Nexus and Mitogen over at axonlabs.io if you're looking to either expand or consolidate aspects of your nootropics medicine cabinet. The show notes for this episode will be online at www.smartdrugsmarts.com, and I will be back at you next Friday, same time, same podcast, and with the same unflagging commitment to helping you fine-tune the performance of your very own brain. Have a great week until then, and as usual, stay smart.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization. Smart Drug Smarts should be listened to for entertainment purposes only, although some guests on the show are medical doctors, most are not, and the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.